In this video we shall understand full adder. Full adder is a continued version of your half adder. In half adder you are going to add 2-bit binary numbers. In full adder you are going to add 3-bit binary numbers. And in full adder you will have 3 inputs, A, B and C in, and you will have 2 outputs, sum and carry. Okay, A, B and C in, these are the 3 inputs, and sum and carry are the 2 outputs that you are going to have. So let us understand the first point. Full adder has 3 inputs and 2 outputs. As I already told you, full adder, it has become fall adder here, it is not fall adder, it is full adder. Full adder adds 3-bit binary numbers. It adds 3-bit binary numbers, 1, 2 and 3. 3 bits are going to be added. I mean 3 bits of binary numbers are added using the full adder. Then we shall go to understand the third point. Okay, so what he says in the third point. So full adder consists of 3 inputs, A, B, C, and 2 outputs, sum and carry. Yeah, that is what we know, right? So it is going, the full adder is going to have 3 inputs, A, B, C, and it is going to have 2 outputs, that is sum and carry. That is all we have already discussed. Then the next point, the block diagram and logic diagram of full adder is as given in the figure, right? So let us go to the figure and understand. This is the block diagram of the, okay, so this is the block diagram of the full adder. You will have A, B, C in as the input, full adder is a block, and sum and carry are the output. Here we have the logic diagram. We are going to have A as input, B as input, and C in as the one more input. A and B are given to the XOR gate, and the output of XOR gate is given to one more XOR gate. And what happens here, the same A and the same B are taken and given to the AND gate, and the output of the XOR gate and the input or C in input is again given to one more AND gate, and then the output of first AND gate is given to XOR gates one input, and the second AND gate output is given to OR gates one more input. It's not XOR gate, it is OR gate. Okay, so OR gate one more input, and the output from the OR gate is what we call it as C out, I mean the carry. Fine. So what happens to the sum? You have A as one of the input, B of one of the input, B as one of the input for the XOR gate, and the output of the XOR gate is given to one more XOR gate. The one more XOR gate, one more input is given as C in, and the output that comes out of this XOR gate is what we call it as sum. Fine. So this is what, so this is your logic diagram. Okay, A and B input are given to the XOR gate. XOR gate output is given to one more XOR gate. C in is given to the XOR gate, and then A and B both are given to the AND gate, and the XOR gate output and C input both are given to one more AND gate. The output of both AND gate is given to the OR gate, and C out is what you are going to get as carry, and the output of the XOR gate here is going to be called as sum. This is the logic diagram of full adder. These are the expressions you need to remember. S is equal to A plus, I mean A XOR B XOR C is what the exact meaning of it, and carry C out is going to be called as A and B, or C input and A XOR B. This is what the expression, if you want to write for sum and carry. If you can remember these two expressions, you remember and write. If you can't remember these two expressions, no need to worry. You just write the answer, you write the block diagram. Okay, you write the block diagram, you write the logic diagram, you write the answer. That is enough. And then we go to understand one more important part, that is your truth table of the full adder. Yes, here we shall try to understand the truth table. And you have the block diagram here. The block diagram that is being shown in the previous slide and this slide, both are same. No need to worry about it. So then we have one more important part that we have to discuss is your truth table. Okay, this is what your truth table is. So let us understand how to understand this truth table. So you have 3 inputs. So we have three inputs in this truth table, and A is one of the input, B is one of the input, and C is one of the input, right? So when you have all the three as 0, when you have all the three as 0, 0 and 0, sum is also going to be 0 and carry is also going to be 0. How many times you add 0? The answer is going to be 0. Sum is going to be 0 and carry is also going to be 0. So then we go to understand the second line. Here what happens? Your A, B both are 0, but C is 1. 0 plus 0 plus 1, that gives you sum as 0 but carry as 1. Sorry, because sum should have been 1, carry should have been 0. Okay, yeah, it's a small mistake over there. Yes, with all the difficulty I have changed the sum and carry interchanged. Okay, so this is your sum, and this is your sum, and this is your carry. So this is your sum and this is your carry. So what happens here? You have A input as 0, B input as 0, and C input as 1. Sum is going to be 1 and carry is going to be 0. So then we go to understand one more thing, that is when A is 0, B is 1 and C is 1. Sorry, C is 0. So the output sum is going to be 1, carry is going to be 0. When input A is 0, B is 1, C is 1, the sum is going to be 0 and the carry is going to be 1, because 0 plus 1 plus 1, 1 plus 1 is equal to 2. As we don't have 2 in the binary number system, we represent it as 0 1. I mean sum is going to be 0 and carry is going to be 1. So this is what happens. So then we have one more input style, that is 1 0 0. Okay, so 1 0 0 gives you the output 1 0. 1 0 0 gives you the output 1 0. What is 1? Sum is 1, carry is 0. 1 plus 0, that is equal to 1. That can be represented in binary number system as sum is equal to 1 and carry is equal to 0. Again I have one more input, 1 0 1. Two ones are there, so that is why the sum is going to be 0 and the carry is going to be 1. Then I go to explain one more similar case. 1 1 0, two ones are there, so that is why sum is going to be 0, carry is going to be 1. 1 plus 1 plus 0, that gives you 2. 2 cannot be represented in binary number system, that is why sum is equal to 0, carry is equal to 1. So then we go to understand the final case, 1 1 and 1. All the three inputs are 1. When all the three inputs are 1, you will have the sum is equal to 1 and the carry will also be equal to 1, because 1 plus 1 is 3. 3 cannot be represented in binary number system, so sum is equal to also 1 and carry is also equal to 1. That is how 3 is represented in binary number system, and this is what the function of full adder. Sir, how did we write this answer? Very simple. Sir, how did we write this answer? Very simple. What we are going to consider here? First point, when all the three inputs are 0, the output sum is equal to 0, carry is equal to 0. Where do you have this? So when all inputs are 0, sum is equal to 0, carry is also equal to 0. Okay, we shall consider, wait. Yes, we shall consider the first point. When all the inputs are 0, the output sum is equal to 0, carry is also equal to 0. When A is 0, B is 0 and C is 0, sum is equal to 0 and carry is also equal to 0. This is the first point. Whatever that we write it from the truth table. Make this very sure. So this is your truth table, and this is your truth table, and whatever that we write it from the truth table. So when any one of the input is 1, consider if any one of the input is 1, this case and this case, all these three cases which I have colored in the same color, we have any one of the input as 1. When we have one of the input as 1, the sum is going to be equal to 1 and carry is going to be equal to 0. Yeah, check it out in the truth table. The sum is going to be 1 1 1, carry is going to be 0 0 0. This is what happens when you have any one of the input as 1. Then we go to understand, when any two of the inputs are 1, the other input is 0, then when any only two inputs are 1, then what happens? Sum is equal to 0, carry is equal to 1. This is what we can understand by using this truth table. Okay, you have two inputs as 1, two inputs as 1, two inputs as 1, the other input is 0, right? So what happens in these three cases? Sum is going to be 0, 0, 0, carry is going to be 1, 1 and 1, right? The same thing has happened in the same color, brown color lines. Then we go to understand, when all the three inputs are 1, when all the three inputs are 1, the output is sum is equal to 1 and carry is equal to 1. When you have all the inputs as 1, the sum is equal to 1 and the carry is also going to be equal to 1. This is what we have written by using the truth table only. The entire answer what we have written using the truth table. Understand the truth table properly and you can write the answer very easily as that is been mentioned here. Okay, so this is what your full ladder is easy. Just understand, you need to write the block diagram, you need to write the logic diagram, you need to write some lines here, and you need to understand the truth table and write the same truth table in the format of answer for working. Okay, and these are the few lines regarding explanation regarding the full adder, and this is what your full adder discussion is. By this we complete two answers, my dear friends. The first one half adder and the second one full adder. Both are very important questions. If you prepare this, minimum say minimum, you will get 7 to 8 marks in the examination. Fine, so prepare well. If you have any doubts, please don't hesitate to ask me questions on WhatsApp.